begin the class by visiting certain common questions we come across in rubber compounding. And last class we saw the comparison between NR and EPDM. So the third monomer in EPDM, it can balance a number of mechanical properties. At the same time, maintaining the resistance to dry hot air of the rubber. And the user looks at the rubber as the most reliable material in fulfilling certain requirements. And we can place that under simple definition, namely the ability to support large recoverable deformation. And rubber products are able to store enormous specific strain energy. So the word specific means for given mass of the rubber, it can support enormous strain. So strain in excess of 300, 400 are quite common. At the same time, uh, not bearing much load. And this flexibility and the dimensional stability are the hallmarks of products. Flexibility and dimensional stability. Having said that, we also require rubber to function as the only material that can do the space filling under different atmospheric condition or environmental situation, both the extreme of low temperature and the high temperature. In addition, most of the rubber products they offer what is called a damping. So damping is a mechanism by which we control vibration. The mechanical vibration, so depending on the product, we can have uh, different levels of vibration control translated in terms of a damping coefficient. Damping coefficient. And you must have studied the extremes of rubber materials are bounded by butadiene and butyl. Butadiene and the butyl. Butyl rubber, known for sluggishness, practically no resilience. And butadiene is the most resilient rubber. All right. And the remaining rubbers can be fit into this extreme. All right. So with that background, let us look at some of the uh, compounding issues. So the questions are not exhaustive what you see here, and we can generate some hundreds and hundreds of doubts in the rubber compounding, and last class we saw. So compounding is a most scientific way of rubber compounding is the scientific way of looking at a rubber formulation or a recipe. All right. And when it comes to the rubber compound, listen very carefully. The base polymer physical chemistry is uppermost. Base polymer physical chemistry. One. And other ingredients we add only with the reference to the base polymer. That's why rightly we identify the other additives as parts per 100 rubber, PHR. All right. And these additives are the ingredients. These additives are ingredients. Listen very carefully. These additives, ingredients, they can have their individual effect and interactive effect. Make a note. Very important. Individual and interactive. The individual effects are meaningful. Yes. I think the recording is on, so I suggest you not to interrupt. All right. If you have any questions, friends, you can come on the video and I can stop. All right. So, in respect of the ingredients, they interact, the individual and the interactive. As a compound, the individual effects are important. And after you have made the product, individual plus interactive. You understand? Individual plus interactive. So when I say interactive, you consider two additives used for the extreme requirements. Take for example a plasticizer. Plasticizer as a flexibilizer, and fillers for reinforcement to make a rubber a tougher solid, and plasticizer to make it a soft, flexible solid. You understand? This is individual and interactive. When it comes to the interactive, we cannot limit to two additives at a time. In number of cases, three additives are common. All right. To give you a feel of it, you consider the plasticizer, the filler, the unreacted or uncross-linked repeating unit in the main chain. All right. Unreacted, uncross-linked repeating unit in the main chain. So that is a basic functionality, rubber. And filler, as we said earlier, that is to strengthen the rubber. And the flexibilizer, to soften the rubber, extend the flexibility to the low temperature. All right. So we see there are three individual and interactive. We can add a fourth one, which is very common in products like tire, conveyor belt, and power transmission belt, and so on. So what is the fourth additive? They are the antioxidants or anti-ozonants, protective agents. All right. So this protective agents, along with the plasticizer, along with the filler, and they offer protection to the unsaturation in the repeating unit. Right. Perhaps you have studied or you may study the polymer chemistry reaction, namely, we come across the protective agents under two major categories. One is to prevent the chain breaking. Another one is the offer the protection from the beginning. Okay, offer the protection from the beginning. So when I say protection, the best example is the antioxidants and certain antioxidants are yes protective agents and certain antioxidants. All right, so they are all protective agents and prevention from chain break. Prevention or the delaying the chain breaking or uh, completely avoid chain breaking, you have a certain additives. Okay, so chain breaking additives are very essential in case of rubber like henna, right? So protective agents are necessary for rubbers like SBR, NBR, isoprene, butadiene, all right? To some extent, chloroprene. You understand? So these are the protective agents. So we call them as the age resistor. That is how we identify. So aging can make the rubber product less rubbery. That is loss of rubberiness. Rubberiness is what? So I will have to remind you of this very important definition: the ability or the potential to support large recoverable deformation. All right. So that is over a period is getting lost for due to various mechanisms, right? One mechanism which we can exercise control is the providing resistance to oxidative degradation. Okay, oxidative degradation, right? Fine. So, friends, you have the 7 questions listed here. They are all pertinent to rubber compounding. So, the first question is polychloroprene. It contains unsaturation and resistance to ozone as compared to the nitrile rubber. But still, nitrile rubber is cross-linked with sulfur, whereas chloroprene cannot. So chloroprene sulfur cure formations are known. Okay, so we'll have to comment this question, very important. So sulfur curable chloroprenes are known, but they are not as common as the sulfur cure for nitrile rubber. Okay, so note this correction, number one. But so keep that qualification aside. Nitrile rubber sulfur cure is very common, and we add the sulfur with the nitrile rubber in the beginning, right? Because the cross linker is so essential to realize the full benefit of nitrile rubber for its solvent resistance. And, sulfur and nitrile rubber, the solubility, there is a mismatch. So what is done is you add the sulfur in the beginning, okay, so that you overcome the solubility issue. Okay, that is one thing. And in case of sulfur, we have at least we come across 2 or 3 variants. One is the elemental sulfur, which is a crystalline. Elemental sulfur, which is crystalline, and cisplatinum or a monoclinic. This sulfur, right, and often causes beyond a particular concentration, it causes what is called blooming, BLOOM, blooming. Okay, so this blooming, it does not have much influence on the mechanical properties, but when we make a thicker rubber products, this blooming is an issue because this blooming, as the term implies, it gives a coating over the surface and on standing. And this bloomed rubber compound, it affects the tackiness. So tackiness, building tack, right? So vital. And in fact, friends, please note, even though tackifier is not given much importance, because earlier NR, even today we use NR in large quantity. So for NR, tackiness is no issue at all. In fact, for NR, it is too much of tack is a problem. But a synthetic rubber, they suffer from lack of tackiness. All right. So what we do, we add the tackifier. All right. So on the one hand, you add the tackifier. On the other hand, you have a sulfur which blooms the surface and affects the tack. Okay. So nitrile rubber, EPDM, and to some extent SBR are known for this bloom. You follow? Nitrile rubber, NBR, EPDM, and SBR, and of course in certain NR formations also. NR formation. So that is about the elemental sulfur. What is the other variant? Amorphous sulfur, otherwise known as the polymeric sulfur. Some identify this polymeric sulfur as the insoluble sulfur. You follow? Insoluble sulfur. So this insoluble sulfur, you would come across certain formulation, particularly the rubber compounds that are necessary for building a thicker rubber products. For example, tire. Tire, there are a number of components. One important component is the carcass. 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 Okay. This carcass, it contains the backbone of the tire. Namely, that contains the real strength offering and load bearing member of the tire. Okay. So this carcass and the rest of the tire products make the tire as a composite. Okay, so more of tire we will discuss. So this carcass compound invariably contain insoluble sulfur. Okay, but there is this insoluble sulfur even at a higher quantity, let's say 3 pHr, no blooming. But one problem is we cannot exceed a temperature of 120. Right? 120 degrees Celsius, even this polymeric sulfur, it gets uh, transformed to the regular crystalline sulfur. So we have problem in processing temperature. So we cannot exceed. So this is about the insoluble sulfur. And we also come across a oil treated sulfur. Oil treated, OT. Oil treated sulfur. Yeah, so as the term implies, this oil treated sulfur, it offers better compatibility with the rubber hydrocarbon. So this is the third variety. The fourth variety, which is common in nitrile rubber, is the MC sulfur. MC sulfur. What is this MC? Magnesium carbonate coated. MC. Magnesium carbonate coated. Okay. Just a minute. This magnesium carbonate coating, it offers qualitatively better compatibility. Why I say qualitatively? There are we have not evolved very clear technique as of now. As of now, we have not evolved a quantitative method. We will discuss the possibility just now. Okay, but qualitatively, yeah, this MC sulfur it promotes the solubility of sulfur and avoids the bloom. Okay, so this is the fourth variant of sulfur. All right. So with this background, we'll have to approach this question. So it says chloroprene rubber unsaturation is present because chloroprene is a chloroprene rubber is a homopolymer, and the repeating unit contains a double bond. Whereas the NBR, it is a copolymer. The acrylonitrile butadiene. It is a butadiene that is getting cross-linked. But it is the cyano group in the acrylonitrile that is responsible for all the reactivity of the nitrile rubber. So what does it say? In spite of this, chloroprene sulfur curing is not so common. Why so? Right? So friends, if you recall, we said the sulfur cross-linking, it can happen ionic as well as radical. Okay, the ionic reactions are quite common. I'm sure some of you could locate the sulfur vulcanization chemistry by A.Y. Koran, right? So he is considered the authority in sulfur chemistry, right? If you have any questions, you can ask me. All right. And so Koran, he describes sulfur cross-linking as a ionic. So for the ionic, so there has to be an abstraction. All right, some element. So in case of abstracting this chlorine is not so easy. Whereas abstraction of hydrogen from butadiene is easy. So that's why the nitrile rubber sulfur cross-linking possible. Chloroprene, it is difficult, even though there are certain formulations that contain sulfur and other accelerator. Listen very carefully. You must have studied for the chloroprene rubber. The accepted cross-linking initiation is the removal of HCl, dehydrochlorination. This HCl is acidic fumes, acidic. Okay, and we require an alkaline. So the alkaline is the magnesium oxide zinc oxide combination. So metal oxide cure, the best example to begin with is a chloroprene rubber. You understand? So that combination, magnesium oxide zinc oxide combination, and in the presence of some organic accelerator like ETU, ethylene thiourea, make a note. Ethylene thiourea, ethylene thiourea. Okay, so this ethylene thiourea, again, it contains sulfur and nitrogen. Okay, so you cannot have the abstraction of certain group from the rubber in the absence of sulfur, but there are exceptions, and we will discuss. Okay, so that is about the first question. Second question is the ethylene propylene. They are hard plastic at 50:50. All right. So once we exceed and that is the up to 50:50. It will be it is like a solid solution, polyethylene polypropylene solid solution. The moment you cross 50 mole percent, what happens? The repeating unit is randomized, right? So one of the requirements for the polymer is the random amorphous. And this randomization makes the copolymer rubbery. One. And two, so beyond that, right, we talk about the EP ratio. You must have studied in EPDM. There are 3 or 4 base polymer variables. Make a note. Very important, make a note. Number 1, EP ratio. Number 2, the molecular weight. And number 3, the type of the third monomer and the quantity. Okay. And number 4, very important, and that is the kind of polymer we use these days, namely, if it is plain rubber or oil extruded. Okay, plain or a OE rubber. So these are the polymer variables. Please bear this in mind. So EPDM rubbers these days, the raw polymer invariably oil extended. Why oil extended? We will discuss later. Okay. So that is about the second question. So what is the third question? We have discussed this already. Okay, that is the sulfur as the cross linker. So fourth question is say 1 to and 1,4. So the reactivity 1, 2 and 1, 4. And 1, 2 is the vinyl, right? So we will have a double bond in the side chain. 1, 2 vinyl, right? So we will have a double bond in the side chain. Whereas 1, 4, it is a double bond is in the main chain. Double bond is in the main chain. This 1, 4 main chain itself, that double bond itself, it's not so active. In fact, it is rather troublesome in respect of ozone attack. But this double bond, after the alpha carbon and beta carbon, that is the allylic hydrogen, make a note. This allylic hydrogen, you must have studied in rubber chemistry. This is an essential requirement of sulfur cross-linking. Okay, allylic hydrogen. This allylic hydrogen, right, it is available in every repeating unit. When in this for the 1,4 addition. 1,4 addition, allylic hydrogen. And we said last class, there is a collision between the sulfurating agent and the rubber molecule, rubber segment or a macromolecule. Not all collision will result in the cross-linking, active collision. So that depends on the frequency factor, active collision. Right? At this point, I must tell you, since we are talking about the thermal stimulus cross-linking and the collision, we'll have to recall your basic school level chemistry, namely chemical kinetics. So chemical kinetics, and this is macromolecule. So that is you have the functionality in plenty. So it is a sulfurating agent that is in a very limited quantity. So therefore it becomes a pseudo first order reaction. Pseudo first order reaction. All right, number 1. And number 2, it follows a simple pseudo first order chemical kinetics, and one can expect the temperature influence. Okay, and in one of the classes they talked about the thermal history. So thermal history is the combination of a temperature stimulus as well as the duration. All right, and for cross linking, it happens for a definite duration at a particular temperature. Let us say 160 degrees Celsius, 5 minutes, right? What happens if I reduce the temperature 150 degree? if we increase the temperature 170 degree, what happens to the time, right? So this has been it has been one of the concerns of the compound designer. Okay, and they employed the chemical kinetics and they found the coefficient of vulcanization. Coefficient of vulcanization, that is based on the energy of activation of a sulfur cross-linking. That energy is about 30 kilocalories per mole. 30 kilocalories per mole. All right. So that is the energy of activation. And in number of cases, they found the coefficient of vulcanization is around 1.522. 1.522. What does it mean? For every 10 degree variation in the cure temperature, I can reduce the cure time by half or increase the cure time by 2 times. Right? So if we reduce the temperature, you increase the time. Say in place of 5 minutes, increase to 10 minutes from 160 to 150. If I increase the temperature 160 to 170, from 5 minutes, you reduce it to 2.5 or 3 minutes. Okay. So this has been helpful in a number of cases. And this is another illustration which says rubber compounding is a compounding has to happen on scientific principle. Okay, so that answers the question number 4. Question number 5. The stiffness of a black filled rubber increases with the increasing black structure, fixed surface area. Okay, 5th question, right? You read the question yourself, right? Read the question yourself. You would understand the carbon black we use, right? It contains 2 essential characteristics. 2 essential characteristics. One is a particle size, which translates in terms of a surface area. Another one is the structure. Okay. By the way, are you able to follow? Am I going too fast? Hello?
No, sir.
What is the class strength, Jayaraman?
51, sir.
ஓ 51 வந்தாச்சா?
சார் இப்போ வந்து 48 தான் சார் இருக்காங்க.
ஓகே. ஆல்ரைட். ஜெயராமன். அனுஷா?
Yes, sir.
Are you able to follow?
Yes, sir.
And the full girl strength is present?
1 minute, sir. Yes, sir. Full girl strength is present.
Okay. All right. All right. So, friends, for the carbon black, so there are 2 essential characteristics, and one can have 2 more, right? We will look into those aspects shortly. But essential characteristics are surface area and the reciprocal of surface area, the particle size. Meaning a coarser particle will have a smaller surface area. Surface area has to be further defined as the specific surface area. What does it mean? Meter square per gram. That is how surface area is expressed. Okay, meter square per gram. All right. So, friends, last class we saw the carbon black is made by furnace process, and the rubber grade carbon blacks are furnace grades, and we saw the scope of ASTM D1765 that describes the effect of carbon black on the cross linking, namely N or a S. N is the normal, S means a slow. Okay, so the cross linking is low, or if there is no effect on the cross linking, then it is N, right? So mostly we use N, okay, normal. And the first numeral, if it repeats, it describes a normal surface area, normal structure. All right. N330, N220, 110, 550, 660. All right. 990, 770. All right. So, friends, the question here is for a given surface area or the particle size, increase in the structure. What is the structure? How the primary particles are aggregated together. So, what does the structure say? Right? Qualitatively, the primary particles are how they are. Do they aggregate in a linear fashion, or do they aggregate in a very closed manner, meaning a spherical or a fibrous? The fibrous, it is the elongated one particle adding another particle. Whereas this spherical could be all collected together. Okay, so the question is, are we the carbon black we use? Is it more towards a fibrous, or more towards a spherical? So fibrous means it is a high structure, right? Spherical means a low structure. That's it. Okay. So the question is, the fibrous can theoretically we can expect the rubber segments to stay or to be trapped by the carbon black particle. Okay. As a result, the rubber chains they become immobile, and along with the rubber, the filler will also support the load, and we notice a higher modulus. So the question is the stiffness. Stiffness combines the product geometry as well as the modulus of the rubber, right? So ideally speaking, the question should have been modulus. So we are talking about the rubber compound or vulcanized rubber. Okay, so strictly speaking, modulus. All right. So let us reframe this question. Why does the modulus of a blank field volcanicity increase with the increasing blank structure? So the answer is blank structure increase means we have a more of a fibrous. Okay, and this fibrous it provides a possibility uh, for the rubber segments to stay on the filler. As a result, when I strain the vulcanized rubber, it is not only the rubber chain, the filler is also taking part. That is the uh, genuine description of the reinforcement. I repeat, filler reinforcement means what? When I filled rubber product when it is strained, the load bearing not only by the cross-linked bridges, along with the cross-linked bridges, filler also takes part. All right. So that answers question number 5. Listen very carefully. Listen very carefully. We simply cannot move on to the next question without understanding what is the scope of the nature of filler and the rubber interaction. Nature of rubber filler interaction. Yeah, this is very important. Listen very carefully. Rubber filler interaction. Are you with me? Hello?
Yes,
Kekrada?
sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
The rubber filler interaction and can we have extensive interaction or weak interaction? So we can, or weak means no interaction. Extensive means and rubber is unable to remain mobile. ரெண்டு இருக்கு. ஒன்று வந்து என்ன, ரப்பர் செப்பரேட்டு, ஃபில்லர் செப்பரேட். இன்னொரு எக்ஸ்ட்ரீம் என்ன, practically we have not spared any rubber segments, even the side chain free ends-ங்கிற இதே இல்லை. So all are held by the filler. All right. இந்த ரெண்டுமே harmful for the filled stock. For the filled stock, ரெண்டுமே harmful. All right. So we'll have to strike a balance. Okay. அதுக்கு தான் we have the variety in terms of particle size and the structure. One. ரெண்டாவது, there is a third variable. Third variable is a surface chemistry. Filler-உடைய surface chemistry. And fortunately in furnace grades, irrespective of a structure or a surface area, surface chemistry, it is a method of manufacturing. All right, as well as the feedstock. இந்த ரெண்டுமே பார்த்தீங்கன்னா சர்ஃபேஸ் கெமிஸ்ட்ரிங்கிறது பெரிய அளவுல கிடையாது. அங்கங்க ஒன்று ரெண்டு, அதாவது சம் ஹைட்ரஜன் காம்பவுண்ட்ஸ், ஆக்சிஜன் காம்பவுண்ட்ஸ், சல்ஃபர் காம்பவுண்ட்ஸ் இருக்கலாம். அது பார்த்தீங்கன்னா எல்லா ஃபில்லர்லேயும் இருக்கும். அவங்களாம் பெரிய அளவில் ரப்பர் ஃபில்லர் இன்டராக்ஷன் அஃபெக்ட் பண்ணும். ஓகே, ஸோ தட் ஆன்சர்ஸ் தி ஸ்கோப் ஆஃப் ஃபில்லர் கெமிஸ்ட்ரி. வாட் இஸ் தி ஃபோர்த் வேரியபிள்? நான் ஏற்கனவே சொன்ன மாதிரி தி structure can it be a fibrous or a spherical? Okay, and here we talk about the particle size distribution, PSD. Make a note, PSD, particle size distribution. Particle size distribution, PSD. So this we have a broader or a narrow distribution. ரொம்ப முக்கியப்பா, கவனமா கேளு. Broad distribution or a narrow distribution. So broad distribution, you may not have much problem in processing. You underline the word processing. You also underline the word dispersion. இங்கதான் நம்ம ரப்பர் ஃபில்லர் இன்டராக்ஷனை எப்படி நம்ம ஸ்டாண்டர்டைஸ் பண்றோம்? டிஸ்பர்ஷன். Okay, in the dispersion, in the PSD is important. Narrow distribution, dispersion is rather critical. Broad distribution, broad particle size distribution, dispersion is a lot easier. Okay. Having said that, narrow distribution may give you a low modulus and moderate TS strength and moderate aberration resistance. Aberration resistance. அதாவது moderate modulus, moderate TS strength, aberration resistance. இது என்னது broad இருந்ததுன்னா dispersion easy ன்னு சொன்னோம். Okay, so we'll have to balance between ease of processing and the terminal properties. Terminal properties. இது மறக்க கூடாது. Okay, all right. So carbon black coming back to this, the structure by the way expressed in terms of DBP number, dibutyl phthalate number, and that is volume of dibutyl phthalate that is retained by the 100 gram of carbon black. 100 gram of carbon black powder எடுத்துக்கிறோம், அதில் DBP drop போடுறோம், and we also make a paste out of it, right? There is a point beyond which the paste has become difficult to move around. So that is the end point. Okay, that is the end point, right? This is DBP number. DBP number, and some call this DBP as the vehicle. Okay, vehicle number. அப்படின்னா என்ன அர்த்தம்? அந்த நம்ம போடுற அந்த DBP in the carbon black particle, it acts as the, and it takes the filler particle along with it. At some point, the DBP number, DBP number, அதனுடைய ஆவரேஜ் மாலிகுலர் சைஸ் பார்த்தீங்கன்னா 30 நானோமீட்டர். 13 நானோமீட்டர். இந்த 13 நானோமீட்டரும் இந்த ஸ்ட்ரக்சர் சொன்னேன் இல்லையா, அந்த ஃபில்லர் அக்ரிகேட்ஸ் ஹவு தே லூஸா பவுண்டா இருக்கா இல்லை க்ளோஸா பேக்கா இருக்கா அப்படின்னு பார்க்கும்போது ஆவரேஜ் சைஸ் பார்த்தீங்கன்னா 13 நானோமீட்டர். ஸோ இந்த சைஸ் அதில் போய் உட்காந்துக்கிறோம். ஸோ இட் இஸ் லைக் என்சமேட்டிக் ரியாக்ஷன். என்சமேட்டிக் ரியாக்ஷன்ல லாக் அண்ட் கீன்னு படிச்சிருப்பீங்க. என்சமேட்டிக் ரியாக்ஷன்ல லாக் அண்ட் கீன்னு படிச்சிருப்பீங்க. அதே மாதிரி தான் தி லாக் வந்து இட் இஸ் தி ஓப்பன்னஸ் இன் தி ஃபில்லர் அக்ரிகேட்ஸ் அண்ட் தட் இஸ் தி லாக். கீ வந்து என்ன? டிபிபி. ஸோ தி டிபிபி மாலிகுல் அங்கங்கே போய் உட்காந்துக்கிட்டு, ஸோ தே மேக் தி ஃபில்லர் பவுடர் இம்மொபைல். அதனால தான் வெஹிக்கிள் அப்படின்னு. இவ்வளோ விஷயம் இருக்கு. இந்த 5th கொஸ்டின் இருக்கு பின்னாடி. ஓகே, சரி. 6th கொஸ்டின் பாருங்க. வாட் இஸ் தி 6th கொஸ்டின்? ப்ரிவென்டிவ் அண்ட் செயின் பிரேக்கிங். இது பிகினிங்லேயே நம்ம பார்த்தோம். செயின் பிரேக்கிங் அண்ட் ப்ரிவென்டிவ். Preventive, as the term implies, at the entry level, the age resistor reacts with the stimulus. நல்லா கேட்டுங்க. At the entry level, age resistor reacts with the stimulus. What is the stimulus? Stimulus is the ozone-like reactive. Ozone concentration level of the matter, parts per 100 million, pphm, not even ppm. ppm na 1 in 10 lakh, and pphm na 1 in 10 crore. 1 in 10 crore. So ppm வந்து 1 in 10 lakh. இது பார்த்தீங்கன்னா 1 in 10 crore. So you can visualize it. And அதுக்காக 1 pphm ஓசோனா பேசுவோம் இல்ல. ஓசோன் சாதாரணமா பார்த்தீங்கன்னா 8 to 20 pphm. இண்டஸ்ட்ரியல் ஏரியா அந்த இதெல்லாம் பார்த்தாச்சுன்னா டபுள் டிஜிட்ல இருக்கும். சாதாரணமா நம்ம in our residential area it will be around 3 to 8 pphm. Okay, so ozone அந்த மாதிரி ஓசோன் கூட இந்த preventive என்ன செய்யணும்? Listen very carefully. Preventive என்ன செய்யணும்? நல்லா கேட்டுக்குங்க. The age resistor preferentially reacts with the stimulus, whereas chain breaking la enna irudhu periya alavula it does not react with the stimulus. Rather, once degradation has set in, it slows down the propagation. Listen very carefully and propagation. See, most of aging, listen very carefully, they are the combined influence of nalla ketukungo, UV radiation 1 and atmospheric oxygen 2 and 3 ozone. The moon சேர்ந்து, right? UV, ozone, atmospheric oxygen. The moon சேர்ந்து, they cause the aging. Okay, and the hydrocarbon rubbers are known for aging. And the aging can be one is prevention, another one is the controlling the propagation. The ரெண்டு தான். At the entry level liye prevent பண்றது. So they are called sacrificial protective agents. என்னாகும்? இந்த they are active antioxidant or anti-ozonants or age resistor. What they do? They directly interact with the external stimulus. இது என்னது? இதுதான் protection. The chain breaking, controlling the chain breaking. அவங்க என்ன செய்வாங்க? Once free radical chains are formed, this additives, the age resistor, what they do? They effectively react with this free radical and make them ineffective. அப்படின்னா என்ன அர்த்தம்? Further propagation is prevented. That is similar to what we saw as the peptizer. So peptizer la enna paathom? Radical scavengers. Adula pathina PCTP, make a note. Okay, pentachlorothiophenol, zinc salt of pentachlorothiophenol. You can visualize the structure. ஒரு thiophenol, phenol structure. So thiophenol you can, and there are 5 replaceable hydrogen in the benzene group. All are replaced by chlorine. All right. So you can visualize the reactivity as well as the stability of the radical. Pentachlorothiazide. இது அப்படியே யூஸ் பண்றது. Zinc salt of pentachlorothiazide. இதுதான் ஒரிஜினலா make a note. It was started by Bayer Chemical. Bayer, they have exited rubber business today. But in the earlier days, Bayer was ruling. The zinc salt of pentachlorothiazole, they identified it as a Renacit 7, RENACIT 7. Okay, Roman letter 7. Okay, மறந்துடக்கூடாது. இதை நீங்க சர்ச் பண்ணீங்கன்னா you will get further this thing. Renacit 7, pentachlorothiazole. ஸோ இந்த pentachlorothiazole என்ன செய்யும்? இந்த கரெக்டான ரியாக்ஷன் டெம்பரேச்சரில் இட் லிபரேட்ஸ் தி ஃப்ரீ ரேடிக்கல். ஏன்னா அந்த தயோஃபினால் ஹைட்ரஜன் ரீப்ளேசபிள் இல்லையா, ஹைட்ரஜன் அப்ஸ்ட்ராக்ஷன் ஆன உடனே தி ஃப்ரீ ரேடிக்கல் சல்ஃபரில் இருக்கிற ஃப்ரீ ரேடிக்கல் இட் இஸ் ஸ்டெபிளைஸ்டு. அட் தி சேம் டைம் இட் ரியாக்ட்ஸ் வித் தி ரப்பர் செயின். ஏன்னா ரப்பர் செயினில் ஏற்கனவே ஃப்ரீ ரேடிக்கல் ஜென்ரேட்டர். So that is isolated. Therefore, the recombination is prevented. So that is the reaction understood in case of the peptides. Similarly, the sequestering agent, that's the right term, sequestering agent. What the sequestering agent do? They effectively isolate the free radicals that are formed, so that propagation is further prevented. Okay, and they are mostly phosphorus bearing compound, one, and some phenolic compounds. All right, all this are chain breaking. Prevention, they are based on amine type. Okay, unsymmetrically substituted paraphenylene diamines. Make a note. PPDs, paraphenylene diamines. This PPDs, they are the preventing. Okay, plus listen very carefully. Plus wax, paraffin wax. This paraffin wax, what does it do? It migrates to the product surface and gives a thin coating on the product surface, and that prevents ingress of oxygen or ozone. And this wax coating will vanish if it is subjected to any straining. So for static protection, wax is okay. For dynamic protection, we need a certain chemical. What are the chemical? That's paraphenylene diamides. Okay, so இவ்வளோ விஷயம் இருக்கு. இப்போ ரப்பர் காம்பவுண்டிங்ல we will have both preventing and chain breaking. Okay, chain breaking, they don't break the chain, please note. So they prevent the propagation. Okay, so that answers the question number 6. Question number 7 and a vulcanized rubber, we call it as a vulcanisate. Listen very carefully. Vulcanization applies to sulfur based cross-linking. sulfur-based cross-link. Okay, and in the literature you come across non-sulfur cross-linked structure also referred as a volcanicide. So, for example, peroxide cure, amine cure, radiation cure, okay, bisphenol cure, urethane cure. ஏன் அவ்வளவு தூரம் போவானே? There are certain rubber blends which are self-cross-linkable without addition of any cross-linking agent externally. Self-cross-linkable. Say, for example, polychloroprin and ENR. Polychloroprin and ENR. அதே மாதிரி polyacrylate is an ester. Polyacrylate is an ester, and polyacrylate and chloroprin are CSM and carboxylated nitrate. CSM என்னது? chlorosulfonated polyethylene. கவனமா கேட்கணும். chlorosulfonated polyethylene. chlorine இருக்கு, sulfonation இருக்கு, chlorosulfonated polyethylene and carboxylated nitrile rubber, XNBR. இந்த ரெண்டு ரப்பரையும் ஒரு டெஃபினட் ரேஷியோல நம்ம பிளெண்ட் பண்ணி, அதாவது மிக்ஸ் பண்ணி கியூர் பண்ணியாச்சுன்னா they get cross link. Very interesting. And so that way, so those cross-linked structure, they are identified as a volcanicide. So keeping that aside, the question here is the volcanicide oxidative aging, change in the stress with the time. That is compression stress relaxation and intermittent the stress, அதாவது strain modulus, intermittent strain, அதாவது CSR ரெண்டுமே பார்த்தீங்கன்னா we measure the effect of aging. We measure the effect of aging. Okay, and this aging is the accelerated aging. So what is the continuous stress relaxation, CSR, not compression stress relaxation, continuous stress relaxation and intermittent stress measurement. இந்த ரெண்டுமே பார்த்தீங்கன்னா they give identical result. There is no difference. அப்படி பார்க்கும்போது okay, what is the question? The question is in the intermittent aging இருக்கே, listen very carefully. Intermittent வந்து we allow certain, we allow என்ன சொல்லலாம், certain comfort zone or atmosphere for certain cross links to reform. Okay, aging need not be, listen very carefully, aging need not be breaking of cross links. Okay, certain new cross links can also form. அதைத்தான் இந்த இடத்துல சொல்றாங்க. Continuous stress relaxation என்ன செய்யும்? It is monotonic. There is a breakage of cross linking. இந்த ISM intermittentல என்ன ஆகுது? Cross link not only they get broken, some new sites they form. Okay, and the results are similar. That is the finding. Okay, and what is the cause behind this CSR ISM giving the similar result? What is the cause? That is cross links they remain unaffected. So aging causes a main chain breakage. Listen very carefully. Cross links are stable. ஆனா ஏஜிங் என்ன பண்றது? CSR இருக்கட்டும், ISM இருக்கட்டும். இந்த ஏஜிங் என்ன செய்யறது? மெயின் செயின். இந்த மெயின் செயின்ல இந்த அலைலி ஹைட்ரஜன், ஆக்டிவ் ஹைட்ரஜன் சொன்ன இல்லையா, அந்த ஹைட்ரஜன் வந்து கெட்டிங் அப்ஸ்ட்ராக்டட். So they get cleaved, right? So the rubber itself is undergoing cleavage, not the cross links. CSR இருக்கட்டும், ISM இருக்கட்டும், cross links are stable. இது எப்ப சாத்தியம்? You may ask, when does it happen, sir? This is a very important question. When does it happen? Super. That is, if you have for the polysulfidic, CSR, ISM will give different result. For a monosulfidic, CSR, ISM will give a similar result. So that itself answers the question. Monosulfidic, carbon, sulfur, carbon, that bond is much more stable than the allylic hydrogen that is present in the main chain. Okay, main chain is more active compared to the cross links. So the chain breakage control பண்ணோம்னா அதுக்கு தகுந்தாப்புல கொஞ்சம் மைல்டு, அதாவது செயின் பாஸ்பைட்ஸ், ஆர்கனோபாஸ்பைட்ஸ் they are effective anti-chain breaking protective agents. Okay, so we notice the difference in CSR and ISAM. In the case CSR, ISM, when do we notice the difference? If we have monosulfidic. Difference monosulfidic, polysulfidic cross. Polysulfidic cross links la dhaan CSR ISM difference seri. Monosulfidic la cross links are same, main chain da affect ஆகும். So main chain பாத்தீங்கன்னா அங்கதான் active sites இருக்கு. They undergo cleavage and they require anti அதாவது preventing the chain breakage to propagate further. Okay, so this is very important, friends. So we have looked at the overall. Now let us see certain typical formulation. Okay, are you with me? You are able to follow? Hello?
Yes, sir.
Yes. So there are not too many formulations. We call them as a gum. Okay, gum formulation. Gum means no filler. So we come across NR without filler, very common. In certain case, chloroprene also. So NR and CR, we have some example of a gum. Other synthetic rubber you don't have. Okay, so what is this gum rubber formulation say? Compound say. This is a conventional cube. Not exactly conventional because the benzothiacyl disulfide, make a note, this is otherwise known as MBTS. இதனுடைய ரியாக்ஷனை வந்து அடுத்த கிளாஸ்ல நம்ம டிஸ்கஸ் பண்ணுவோம். ரிமைன் மீ. ஓகே, MBTS, ரைட்? ஸோ தட் இஸ் ஒன் பார்ட். அண்ட் பூஸ்டர் இதான் அது வந்து TMTD, தையூரம்னு லாஸ்ட் கிளாஸ்ல சொன்னோம். தையூரம் booster. Another quantity paranga 0.1. Okay. Now you can imagine the need for the dispersive quality. 1 and a 0.1. So they are primarily responsible for getting a homogeneous rubber product. And the quantity added is much less. At the same time, we'll have to ensure the best dispersion. Best dispersion means irrespective of the sample size, the relative ratio must be identical. Whether I use 100 gram or 100 milligram, 100 kg, the ratio between the rubber and this particular active chemical. Okay. And equally important is the antioxidant 6-ppd. இந்த இடத்துல antioxidant சொல்றாரு. Okay. It also qualifies as the anti-ozonate. 6-ppd anti-ozonate. Other quantity 1 part. Right. And what does it do? It is the protective agent. Okay. Protective agent. 1 part. Zinc oxide 5. And this is a stable combination. Zinc oxide 5, stearic acid 2. And these two form the cure activator. And you have the process oil just about 2 parts. You may ask, we don't have filler, sir, but we are using a process oil. But what is the quantity? Not as a flexibilizer, just to enable the addition of other powdery additives. அவ்வளவுதான். Powdery additives in sulfur, cure accelerator, zinc oxide. இவங்கெல்லாம் என்ன செய்யணும்? They effectively get into the rubber, right, without any difficulty. In order to ensure that this process oil, what does it do? That is important. What does it do? They rather physically interact with this powdery additives and reduce the surface energy. Reduce the surface energy close to the rubber. Okay, this surface energy similarity is important for the dispersion. All right. So process oil added here is not to help in the filler addition. This is a gum rubber, no filler. 1 and 2, not for the flexibilizer, because NR is known for low temperature flexibility maintained up to -65. Arude TG -70. But after vulcanization, there is certain increase in the TG. But -60 for sure, TG is assured. Okay. So process oil role in that is to make other powdery additives easy to get into the rubber, so that dispersion is effective. புரிஞ்சுதா? ரொம்ப முக்கியம், boys. All right. And look at the hardness. Okay. Usually gum rubber of NR, not only NR, CR, SBR. Okay. You can safely consider the hardness is about 35 to 40. Sure. Right. Tensile strength very high. There is no synthetic rubber with the exception of fluorocarbon and chloroprene. But எல்லா ரப்பரும் பார்த்தீங்கன்னா tensile strength of a gum rubber will be poor. Single digitல தான் இருக்கும். NR மட்டும்தான் 20 plus 24 MPa. And what is the breaking elongation at break 750? அப்படின்னா என்ன அர்த்தம்? This is one rubber which can store enormous strain energy. அதனால தான் load bearing application எல்லாமே NR products. Load bearing application like tires we use for the truck, conveyor belt, engine mount, diaphragm. Okay, இதெல்லாம் பார்த்தீங்கன்னா NR based load. அடுத்தது filled rubber. Filled NR. So why we do the filling? For various hardness. Hardness can be, அதாவது ப்ரீவியஸ் கேஸில் கம் ரப்பர்ன்னு என்ன பார்த்தோம்? Gum rubber giving a hardness of 39 or of 40. But in the case, I require hardness variable. Okay, 50, 60, 70 hardness. And what happens to the tensile strength? It is 20 plus safer. Safe 20 plus. What is getting affected? It is the elongation. From 750 reduced to 600 and 550. Because a large elongation in number of cases makes the product handling difficult. Adanaala, too large elongation is not advisable for certain rubber products. Okay, so how we get a different hardness, right? I vary the filler. So what is a filler? This is N550. What does this 550, otherwise known as FEF? எழுதிக்கங்க. FEF. Fast extrusion furnace. Fast extrusion furnace. So the emphasis on the extrusion. Extrusion na எப்பவுமே extrusion இல்ல. It could be a calendering, molding. In general, for enabling processing, rubber compound has to be processed smoothly, right? And which filler can help? It is this 550. This 550, the particle size, average particle size is from 45 to 55 nanometer. And this surprisingly has a high structure compared to its the previous, அதாவது low particle size or a large surface area N330. அந்த N330 விட இதனுடைய ஸ்ட்ரக்சர் அதிகம். அதனால most of the molded rubber products we use this N550. என்ன அர்த்தம்? coarser particle but a high structure. Coarser particle என்ன செய்யும்? Processing போது moderate heat buildup. பெரிய லெவலில் heat buildup கொடுத்து காம்பவுண்டை பால் பண்ணும். Moderate heat buildup, but after vulcanization, the structure that is present is able to give you high modulus. இவ்வளவு விஷயம் இருக்கு N550 மறந்துடும். And how we vary 25, 50, 70. So process oil இங்கேயும் அதே application. Okay, powder வந்து to make it amenable to get into the rubber. So cure accelerator combination அதே தான். Sulfur வந்து ஏன்னா filler வந்து ஏன்னா அது வந்து gum rubber. Filler போட்டதுனால rubber is getting diluted. Effective quantity is diluted. And some filler might hold the sulfur, certain percentage of sulfur. So அதனால in order to balance the cure activity, கொஞ்சம் higher quantity போடலாம். No harm. Okay. All right. So properties பாருங்க, hardness பார்த்துட்டோம். And the moment we add filler, the modulus at 300%. இதுதான் rubber modulus at. Modulus at 300%. இது ரொம்ப முக்கியம் ஃப்ரெண்ட்ஸ். இதுதான் the real reinforcement capture. Okay, filler reinforcement capture. அது எப்படி இருக்கு பாருங்க, கிராஜுவலா 7, 9, 11 அப்படியா. Tensile strength comparable. Elongation at break is reduced. Okay. And the hardness, increase in the hardness, what does it say? Increase in the hardness, right? Makes the rubber so makes the rubber durable for unexpected tearing situation, unexpected abrasive situation. Okay, in general, make the rubber durable. Rubber product durable. அதுக்காக தான் filler போடுறோம். All right, and that is measured in terms of hardness. Okay, next comes இந்த table பாருங்க. இந்த table it is filler containing SBR. SBR 1500. So this is the rubber emulsion rubber. 1500 வந்து emulsion rubber. All right, emulsion rubber, what does it do? ரொம்ப முக்கியம். Among the SBR grades, emulsion processing is better. 1 and 2. And high molecular weight. There is a possibility of a high molecular weight. And genuinely rubber. அப்படின்னா என்ன அர்த்தம்? ஸ்டைரினும் பியூட்டாடைனும் randomize. Genuinely rubber. Randomize. There is no question of butadiene alone or a styrene alone adding. Okay. Genuinely rubber. So SBR emulsion. And filler. அடுத்தது அப்போ N550 ன்னு பார்த்தோம். N330 இங்க யூஸ் பண்ணோம். என்ன சார் வித்தியாசம்? அங்க பார்த்தாச்சுன்னா 550 for the molded rubber products. For the molded rubber products, NR based 550 is ideal. N330 for the abrasive situation, abrasion resistance. Anga வந்து N550 is able to offer the balance between the durability as well as process. In the case durability தான் tops the list. Processing வந்து emulsion grade processing you must have studied is lot easier. You understand? இந்த இடத்துல properties ரொம்ப முக்கியம். Processing-ஐயும் தாண்டி properties போது tensile strength. ஏன்னா NR gum can give you tensile strength of 24 MPa. இது filler போட்டாதான் SBR. ஏன்னா SBR is an amorphous rubber, and this is one rubber which very well responds to filler reinforcement. And sulfur, you see, quantity is reduced. 2.5 reduced to 2. Why? Idila butadiene வந்து it is about 75 mole%. And we cannot add too much of sulfur and introduce polysulfide. Polysulfide cross-linked network weaken. NR la okay, no problem. இங்க பொறுத்தவரையில கொஞ்சம் ஆக்சிலரேட்டரை நம்ம அதிகமா யூஸ் பண்ணுவோம். அதனாலதான் MBTS அங்க 1 பார்ட் போட்டது, இங்க 2 பார்ட். TMTD அங்க 0.1 போட்டோம், இங்க 0.15. இது ரொம்ப முக்கியம் ஃப்ரெண்ட்ஸ், கவனமா படிக்கணும். ஓகே, சரி. அடுத்தது பியூட்டைல் ரப்பர். பியூட்டைல் ரப்பர் இருக்கிறதுலயே இருக்கிற ஹைட்ரோ கார்பன்லயே 2 வகையா பார்க்கலாம். அதாவது it is difficult to process and one rubber that holds a lot of secrets then what is revealed. Butyl rubber வந்து butyl 268, it's a common grade. 268 is a common grade. All right. And this butyl 268, the isoprene mole percent is about 2.2 or 2.3, just right. Right? Isoprene. Isoprene, why we need isoprene? To cause sulfur cross-linking. All right? And sulfur, how much I use? 2 parts. And look at the Cure activator, Cure accelerator. It is not the MBTS, it is the TMTD. கவனமா பாருங்க, TMTD. And MBT, mercaptobenzothiazole. அதாவது MBTS வந்து டைமர் ஆஃப் MBT, mercaptobenzothiazole. ஆனா இந்த TMTD 1 பார்ட் அதை நம்ம மிஸ் பண்ணக்கூடாது. அதுதான் இந்த பியூட்டைல் ரப்பருக்கு மோஸ்ட் அப்ரோப்ரியேட். ரைட்? திஸ் TMTD இன் NR or in SBR at 1 part may cause fast curing, அதான் ஸ்கார்ச்சின். ஆனா பியூட்டைல்ல அதுதான் பிரைமரி கிராஸ் லிங்கர், அது மறந்துடக்கூடாது. பிரைமரி கிராஸ் லிங்கர். ஏன்? ஐசோப்ரின் வந்து 2 மோல் % தான் இருக்கும். அதை வந்து நான் எஃபெக்டிவா யூஸ் பண்ணணும் அப்படின்னா TMTD தான் நான் போடுறேன். TMTD இஸ் தி அல்ட்ரா ஃபாஸ்ட் ஆக்சிலரேட்டர். MBTS என்ன? டிலேடு அல்ட்ரா ஃபாஸ்ட். டிலேடு அல்ட்ரா ஃபாஸ்ட் ஆக்சிலரேட்டர். ஓகே, மறந்துடக்கூடாது. And filler N330, sulfur 2 parts. சில இடங்கள்ல 2 parts எல்லாம் கொஞ்சம் அதிகம். ஏன்னா இது இன்னர் டியூப் ரெசிபி மாதிரி தெரியும். இன்னர் டியூபுக்கு இன்னும் கொஞ்சம் ப்ராசஸ் ஆயிலாம் போடணும். இது வந்து பியூட்டைலோட டெஸ்ட் ரெசிபி நம்ம எடுத்துக்கலாம். பியூட்டைலோட டெஸ்ட் ரெசிபின்னு எடுத்துக்கலாம். அண்ட் வாட் இஸ் தி எலாங்கேஷன், டென்சைல் ஸ்ட்ரென்த்? ரொம்ப பிரமாதமா 16 MPa and elongation 500%. Very comfortable. Hardness 60. Okay. So we stop at the table 2.5. There are few more recipe to discuss, a typical recipe that we will see next class. Next class on Monday. Monday தானடா கண்ணா? Jaraman? Hello?
Yes, sir. Yes, sir.
Monday, first
Monday, first 2 hours.
Okay. Either I will do it from home or from the department. But this class is recorded, and I stop here, and I also want to take attendance. Right. I stop here, friends. You have any questions, sir? Any quick questions? All right, I stop here and stop the recording also.